Hey guys, Mr. O'Sullivan here. Hey, we're getting ready to go through homework problem AB number 4. And again, before we start, quick thanks to Jeff Osborne, AP Calc teacher at Central Columbia High School in Bloomsburg, PA, for providing this problem. Let's see what we have. So it starts out, stem of the problem tells us both f of x and g of x are differentiable on the interval, closed interval 0 to 6, again, which is also just as good as telling us that f of x and g of x are continuous on that very same interval. It is known that f at 0 is equal to -2. The graph of f prime consisting of 2 line segments is shown below. Okay, so I'm looking at, that's the graph of f prime. And then a table of values for g of x, g prime of x, and g double prime of x is given for these various x values. So part A asks, at what value of x does f of x have a relative maximum? Okay, and then also have to remember to give a reason. So f of x has a relative max where f prime of x changes from positive to negative. I should probably say changes there. And so if I look at the graph of f prime, I can see right here, prior to x equals 2, the value of f prime is positive, and then after x equals 2, the value changes to negative. So I've identified, I'm just going to say this occurs at x equals 2. Okay, so there's my justification. I've identified the x value. Okay, part B, at what value of x does g of x have a relative minimum? And then give a reason. Okay, so now I'm changing gears. I'm looking at my table with the g prime, and g double prime values. And I want to identify where g of x has a relative minimum. Well, I know that g of x will have a relative min when g prime of x equals 0 or is undefined. Okay, and I also know by the second derivative test that g double prime g of x will have a relative min when g double prime of x is positive. Okay, which would make sense because that would mean that g of x would be concave up, and that would lead to a relative minimum. Okay, so I'm back to my table. I'm going to look for these 2 criteria and see if there's an x value that meets both those criteria. So g prime of x has a value of 0 for an x value of 2 and x value of 4. And now the other criteria, I want the second derivative to have a positive value. So that's going to be positive 2. And so my x value, where that occurs, is x equals 2. So I'm just going to say those 2 criteria, this occurs at x equals 2. Okay, not too bad. All right, moving on, part C. Okay, just kind of again restated the stem of the problem, the graph, and the table. Write an expression for f of x that includes an integral. Use that expression to find the values of f at 2 and f at 5. Okay, so now this piece of information, the stem of my problem, where I'm given that f at 0 is equal to -2. Okay, so we kind of start doing this. I'm going to just set up f of x. It's going to be equal to a definite integral Now my lower bound for my definite integral is going to be this x value that I'm given in my initial condition f at 0 equals -2. So I'm going to say that, starting it out by 0. Let me do a restart on that, kind of botching it. We can kind of jump right to what f of x is going to be. F of x is going to be equal to the -2 plus my definite integral with the lower bound of 0, upper bound of x, and then it's going to be f prime, and I'm just going to use a different variable, kind of a dummy variable other than x. I'm just going to say f prime at t dt. Okay. If that's not crystal clear in your head, you can think of it like this. If we just started with a definite integral, a and b, of f prime at t dt, then we know we're going to have, according to the fundamental theorem of calculus part 1, the antiderivative of f prime at t, which would be f, and it's going to be at the upper bound, minus f at the lower bound. And all we're doing is we're just kind of substituting in. We want our upper bound, since we want a function of f of x, we're just going to substitute x in here. So this is going to give us f of x. And then our lower bound, we're going to change this to 0 because our initial condition gives us a value for f at 0. And that's our -2. And then if we just rearrange this for f of x, we have that equation right there. Okay, so now once we have that equation, we want to find f at 2 and f at 5. So I'm just going to substitute in. F at 2 is equal to -2 plus the definite integral from 0 to -2 f prime at t dt. Okay, so to evaluate this, I have to go to my graph, and I'm interested in the definite integral from 0 to, I don't know why that's -2. Looking at my graph and I'm seeing I don't have a -2. I'm in trouble. That should be 0 to 2. Sorry about that. So let's fix that. So definite integral from 0 to 2. So now I'm looking at my graph. I'm going from 0 to 2. So I'm interested in this region, that triangle. So that's 2 by 2. 1/2 the base times the height. That's going to be, has an area of 2. And so that's going to be equal to -2 plus 2 is equal to 0. F at 5 is equal to, again, -2 plus the definite integral from 0 to 5 f prime at t dt. It's going to be equal to, okay, so now I'm going all the way from 0 all the way to 5. And so I have to include that area I just found, but now I also have to be cognizant of this area of this triangle where the function is below the x-axis. So it looks like I've got base of my triangle is 1, 2, 3 units, and the height of the triangle is 1 unit. And so I'm going to say 1/2 base times the height. The area of that triangle is going to be 3/2. And again, now what I have to look at is, because the function is below the x-axis, I'm going to reckon that 3/2 as -3/2. So that's going to be -2. Don't want to forget my -2 there in the front. And then my definite integral is 2 plus 2, just like I had above for f at 2, and then plus -3/2. Okay, it's a numeric answer. I can stop right there. Okay. Part D, find the absolute minimum value. Okay, as soon as I see the word absolute minimum value, I'm thinking table time. So I'm setting up my table, got X. The right column of my table is going to be the function that I'm looking for the absolute minimum of. So that's going to be f of X. And I know I need to include my X values, my endpoints, so 0 and 6. And then I also have to have any other critical numbers. So endpoints, EP, those points, and then any critical numbers. And if I'm looking for an absolute minimum, I can kind of narrow down the critical numbers that I'm going to consider. Again, a minimum would be where my derivative is going to go from negative to positive. So if I go up and I look at my graph of f prime, I'm interested to find where my derivative f prime goes from a negative value to a positive value. Looks like that would be right here, where it's negative right before 5, and then it changes to positive. So I have to consider a critical number of x equals 5. Okay. Now I have to just find, okay, what are the values for each one of these? So f at 0, I'm given that, right? F at 0 is equal to -2 is my initial condition. F at 6, I haven't found that. F at 5, I just found that. That was what I have right here. That was -2 plus 2 plus 3/2. And again, I'm looking for the absolute minimum value here. Just so I don't get a kind of a brain cramp on this last one here. -2 plus 2, that cancels out. So this is just going to be -3/2. Okay. So far my absolute minimum value is -2. Now I got to look at f at 6. So f at 6 is equal to -2, 0 to 6, f prime t dt, that's going to be equal to the -2 plus the 3/2 that I have. Sorry, -3/2. But then plus, I'm going to have this last little bit right here. Well, that's just going to be 1 unit by half a unit. So base times height times a half, that's going to be 1/4. So that's going to be plus 1/4. Well, adding that 1/4 isn't going to, keep this in the running for an absolute minimum, because it was the value of this, but then I just added 1/4 to that. So I just know this value, -2 plus -3/2 plus 1/4. My absolute minimum value looks like it is -2. So the absolute min equals -2. Okay, I'm just confirming they're asking for the value, not the x value where the absolute minimum occurs. Okay, and the analysis that leads to the answer, that's the beauty of the table. It's right there. Okay. Part E, on the interval 0 to 6, is there a value of c such that g prime at c is equal to -2? Okay. Well, if I'm seeing the wording here, is there a value of c such that, I'm thinking theorem. So I know this is related to a theorem. Now I just have to kind of lock down which theorem it is. Well, it's looking to me, I'm kind of thinking what's in the running. I'm thinking it's probably going to be either maybe an IVT or mean value theorem for derivatives, probably, looks like, because I'm dealing with the G prime at C. Okay, so let's see if we can we're looking at the interval 0 to 6. This is where we're given, we're looking at our table of the G prime, and G double prime values. Okay, well, if it's an IVT problem, we basically have to make sure, okay, if it's IVT and we're talking about G prime at C is equal to -2, well, then we're saying that G prime at C, I should have first off, I got to make sure that G prime at C is continuous. Okay, well, I know that it is because they tell me that G of X, actually, I don't know that. I mean, they tell me that g at x is differentiable, and so g of x is continuous. But I don't know that I know the derivative of exists for g of x, but I don't know that the derivative g prime is continuous because they haven't told me that. Now, if they would have said that g of x is twice differentiable, then that would have been sufficient. So I'm not even sure that I have that. So I'm going to look at mean value theorem for derivatives. Well, that's telling me if it's the mean value theorem for derivatives, and this is my conclusion, then this is, I'm saying, all right, my conditions, MVT for derivatives, and if this is the conclusion, g prime at c is equal to -2, that must have meant that g at x was continuous on our closed interval 0 to 6. It also had to mean that it was differentiable on the open interval 0 to 6. They told me that in the stem of the problem. So I've met both of those criteria. So if that's the case, then I know what? Then there is at least one x equal to c in that open interval 0 to 6 such that, and here it comes, such that what? G prime at c is equal to, that would be the slope of the tangent line, is equal to the slope of the secant line at the endpoint. So I'm looking at g at 6 minus g at 0 over 6 minus 0. And then I've just got to confirm that. I hope I got those values in the table. So g at 6 is -3 minus g at 0. G at 0 is 4. Six minus 0. Well, that, if I work this out, I get -7 over 6. Okay, and so I don't have I haven't, it's not equal to my value of -2. But what I can do is I can look at, I think this is what kind of makes this problem, raise it to like another degree of difficulty, is in that interval, it doesn't have to be, only from 0 to 6. Is there an interval somewhere in between there where I am going to have a slope of the secant line where it is going to be -2? So I'm going to look here. I'm going to kind of break this down. And I'm thinking, well, what if I take, it looks like from, I think right here is what I've got. Actually, let me try that pair of points. Because if I try that, that's going to be 4 minus 0 over 0 minus 2. I think that's going to work for me. So that'd be 4 over -2. Bingo, bango, bongo. That's going to be equal to -2. Okay, so it is, I'm going to kind of restate this part of my problem. So g prime at c equal to -2, and I kind of found my interval, and it's going to be, it's actually g at 2 minus g at 1. G at 2 minus, I'm sorry, g at 0. And then g at 2 is 0. Wow. Driving the struggle bus. Let me get that again. So that's over 2 minus 0. That's equal to g of 2. We'll get it. G of 2 is equal to 0. G at 0 is equal to 4 over 2. So that's going to be equal to -2. Okay, that was somewhat painful, but I think we persevered and got there. Part F, last part of this, find the value of this limit. The limit as x approaches 2 of f of x over g of x. Show all supporting work. Okay, well, first thing we want to do is plug and pray. So we're going to look at limit as x approaches 2, and I want to plug that into upper function. So that's going to be I want to make sure as I'm setting this up, because what I don't want to do is I do not want to write this. I want you to look at this long, and I think this is what you have to do. So I'm starting with this, and I don't want you to say, well, gee, I just plugged that in. That's just going to be f of 2 over g of 2. Well, let's see, f of 2. That's familiar. Oh, we found that. That was in part C. F of 2 is equal to 0. And then g of 2, we're going to the table for that. G of 2 is equal to 0. So we get that. Okay. Do not want to write it like that, because you're basically saying that the limit cannot be determined of that expression, that you're getting 0 over 0. So what we want to do is we want to break this up and look at the numerator and the denominator separately. So I'm just going to write, it seems like more work, but it's mathematically, it's what we need to do. So the limit as x approaches 2, f of x is going to lead to f at 2, which is equal to 0. And then for the denominator, the limit as x approaches 2 of g at x is g at 2, which is also 0. So 0 over 0. So we see this, and we can use L'Hopital's rule. So now what we're going to look at is a new expression, the limit x approaches 2 of f prime of x over g prime of x. So again, at this point, we want to break it up. Limit x goes to 2 of f prime of x. And then the denominator, the limit as x approaches 2, g prime of x. Okay, so I'm going to look at the bottom. G prime, I know that is in my table. So g prime of x as x approaches 2, still 0. That's going to be a problem. Could be. I guess it could be undefined if my numerator comes out to be some number other than 0. So that's going to be 0. And now I'm looking at my, this is pretty easy because this is the graph of f prime. I just want the graph of f prime. That's going to be f prime at 2. F prime at 2, looky there, there it is, it's 0. So bam, got it again. So the limit of the numerator is equal to 0, limit of the denominator is equal to 0, indeterminate form. I see that, and I'm doing L'Hopital part 2. Okay, so limit x approaches 2 of f double prime of x over g double prime of x. Again, as long as we keep coming up with that indeterminate form, either 0 over 0 or infinity over infinity, we can keep applying L'Hopital. So now again, we're going to break it up. So the limit of as x approaches 2 of f double prime of x, and then the denominator, the limit as x approaches 2 of 2 g double prime of x. Okay, well, I know that's in my table. G double prime as x approaches 2 is 2. Now, the limit as x approaches 2 of f double prime of x. Well, what I'm interested in now is not the value of f prime, but I'm looking for the slope of that line right there. Well, that line looks to me, I can just kind of check. Got a corner here, looks like I'm going down 1, right 1. So that'd be -1, +1. So my slope is -1. So that's the value of f double prime at 2. So that's going to be equal to -1. So my answer, since these are not 0 over 0, and I can bring this together and I can have my answer is equal to -1/2. So that is the answer to my original limit expression. Okay. All right, guys. Hope that helps. Thanks.